So our topic is measurement, specifically time measurement. So first in our presentation we'll discuss the history of measurement, but we'll focus on time measurement, and we'll provide interactive and hands-on activities that you can do in the classroom. We'll discuss the instructional methods, and we'll provide methods for assessing the student's understanding, and finally we'll summarize.
Okay, so as with all things in math and everything, all history can be traced to the main civilizations such as the Egyptians, the Mesopotamians, the Babylonians, the Greeks, and the Romans, right? They're like at the basis of everything. And each civilization influenced one another, like through cultural diffusion and trade. So in terms of measuring length and weight, each civilization relied on body measurements, and we saw this in our class when the first activity that we did in class would have you measure a foot. Remember that story that we all read?
Yes.
And that we did that activity. So that originated obviously from this type of measurement that later led on to a standard measurement. And then since everybody's body is different, and everyone had a different way of measuring, like this means 1 pound, or the length of an arm is something, obviously this caused problems with that, right? So this is why a standardized method of measuring needed to be created, and it was created in the 16th century.
So the first methods of keeping time are based on the sun and the moon. And based on these celestial observations, the sun clock and water clocks were created. And then later on, mechanical and atomic clocks were created. A key component to telling time is attributed to the Babylonians with the base 60 number system. And that's why we have 60 minutes in 1 hour.
So, as Catherine said before, the first things that people used to observe, they used to observe the celestial objects to calculate time and passage of time. So one of the first things was sun clocks, and what the Egyptians did, they did the obelisk and shadow clock in 3,500 BCE. How this came to be was that people saw that the sun shone for X amount of hours during the day. So the first sundial clock was created by putting a stick in the ground and watching the shadows go by, and then it later evolved into using obelisk, which is this thing right here. And let's see. After that, the Egyptians made a shadow clock around 1500 BC, and it divided the day into 10 parts, and it also had 2 twilight hours in the morning and the evening. And then after that, they calculated that there were 12. They made this division of 12, which is also like the basis of today, like 12 hours in a day or 24 hours in a day.
And then after the sun clocks were created, water clocks were created. And one of the first water clocks was discovered in Egyptian pharaoh Amenhotep I, who was buried in 1500 BCE. And the Greeks took this water clock and made it more elaborate, and they called their water clock clepsydras, which means water thieves in Greek. There were 3 different versions of these clepsydras. One of them was a stone vessel that had sloping slides. It looked like a bowl, and it had a hole at the bottom, and the water would drip from the hole, and they measured the drips. And the second one was a cylindrical or bowl-shaped container that filled up with water. So this one was different because the other one lost water, and this one, the water went into it, and you could measure the time based on the markings around the bowl. Those were actually standard hours inside the bowl. And then the third one was a metal bowl with a hole at the bottom, and this bowl was placed into, it looked like a bath. We have a picture coming up, but it looked like a bird bath, and this bowl was placed inside of it, and at certain times during the day it would sink, and at certain times of the day it would float. So that's how they measured time using that version.
So this is a picture that shows about it also says the Greeks and Romans.
Can you speak louder?
Speak louder?
Yeah.
Okay. So the Greeks and Romans also used this method of telling time. And then they had bells and gongs and windows and doors, which acted as the dials. And then Andronikos supervised the construction of this clock, called the Orologion, also known as the Tower of the Winds, in the 1st century BCE. And this also had the 24-hour
it had a 24-hour clepsydra inside of it, and it had indicators for the 8 winds, and that's where it gets its name from, the Tower of the Winds. It also showed the 4 seasons of the year.
So besides them, also the Chinese are known for this type of method of calculating time. And the Chinese made the Susong water clock in 725 BCE. It was 30 feet tall, and as you're going to see the picture, that is very elaborate. So this is the picture.
So it had all different decorations. It actually had like little mannequins that popped out to let you know what time it was. So I don't know if you've ever seen a cuckoo clock, but it's kind of like that within the tower. And then after we had the Susong water tower, we have the mechanization of clocks, which means mechanical clocks. Peter Henlein of Nuremberg created the spring-powered clock in the 16th century. These clocks were small and portable. This was the first time that clocks were ever really portable. And then Christian Huygens, a Dutch scientist, invented the pendulum clock in 1656, which had the most accurate time so far. It only had an error of 1 minute per day. And then he almost perfected it. He got the error down to 10 seconds per day. He also made the balance wheel and spring assembly. And then William Clement of London, we could be related, I'm not really sure. I originally was going to say great-great-grandpa William, but then I didn't see the last name. But he created the recoil escapement clock that was better than the Virgin Foliot escapement clock. The recoil escapement made the clock lighter. Escapement just means that it's the mechanism for how it ticks. So the recoil escapement used levers and weights that were lighter than those that were used in the Virgin Foliot escapement. So basically the clock was lighter than the Virgin Foliot escapement clocks.
Okay, so after that there were more improved mechanical clocks. And George Brand improved the pendulum clock's error to less than a second, because before it was like closer to 1 second. Then John Harrison improved Graham's clock by reducing the friction of the pendulum. And after that, Sigmund Reifler's pendulum clock of 1889 had an error of 100 of a second. And then Prude perfected the pendulum clock. And then it was replaced by Short's clock in 1921. So you see how like each clock was improved by the next inventor. And also you see science, because with reducing the friction is like something that we see in science, right? So this whole topic can also be integrated into a science lesson or teaching science, because you start off from like the beginning of teaching of calculating time based on the celestial objects, and then if you look at the history, you see how each one influences the other and how it becomes more improved and more improved.
Can you go back? We clicked at the same time and went 2 slides forward.
I don't want to go back.
Okay. And then we moved on to more contemporary clocks. The quartz clocks were created in the 1920s, which is about 90 years ago, so it's not too far away from us. The quartz crystals vibrated in an electric circuit and created an electric signal